Okay, so I'm going to go ahead and go through the solution of a couple of problems that were posted. The first part dealt with this slide at a fair, and I went through that online, so you can read about that. And the other two things are two other questions. I'm actually going to solve this two ways, and it'll be two different videos. The first way, I'm going to use acceleration and kinematic equations, and the second way I'll do it with work energy. Okay. So from the previous question that I posted, I had the following. Here's this slide fair like this. They're not straight, but this is just an approximation. Let's say it's angled at 25 degrees, and this is 5 meters high. And then here's a child, or adults, because you know adults can use the slide too. So, and they're going to slide down. And the first question is, how fast would they be going at the bottom? That's not a very good picture. And from that, I also determined that the coefficient of kinetic friction was 0.31. Okay. So when we have a problem like this, clearly there are forces involved. So we want to draw a force diagram, a free body diagram for the child. So if I do that, here's my, actually before that, maybe a better thing would say, okay, what are the x and y axes? You know, they're not real, so we can really choose whatever we want. In this case, I know that the child's going to be accelerating that way. So if I choose the x-axis to be that way, and then I want the y-axis to be perpendicular, that's going to be nice, because then I'll have an acceleration in just one of the axis directions, and that makes things a little bit easier. Okay, so here's my child. And what forces do I have? And let me redraw my axes just to make it clear. There's the x-axis and the y-axis. So what forces are acting on the child? Well, gravity's pulling down. And gravity pulls straight down, so this is going to be, I'll write it as mg, where g is the gravitational field vector and it points straight down. And m is the mass of the child, which we don't know. But, you know, don't let things like that stop you, because hopefully in the end, things will work out. Maybe they won't. I don't know. We'll have to find out. Okay, so what else is pushing on the child? Well, what's touching the child? The slide. And the slide can push in two ways. It can push perpendicular to the slide and parallel to the slide. So this is going to be, I'll call this, I normally call it, this is called N. It's usually called F sub N or something like that, but that's the normal force, normal meaning perpendicular. And then if the child's sliding this way, there's going to be a friction force this way. F friction. Okay. Now, also I know that this angle is 25 degrees, and so this is a right triangle right there. So this is the complement of 25, so that's also 25. Just a little quick geometry there. This comes up enough that you see it a lot. Okay, so I want to find the acceleration in the x direction, and that depends on the frictional force and part of the gravitational force. So I need to go ahead and let me go ahead and write down Newton's second law. It says in two directions, because it's a vector equation, F net in the x direction is ma in the x direction, acceleration in the x direction. F net in the y direction is may. Now, as this block moves down the slide, it doesn't change its motion in the y direction at all. So that vertical acceleration is 0. So this says that F net y. And you'll see that I care. I need to do this first, because what's the model for friction? The model for kinetic friction says the frictional force, Ff, the magnitude, is equal to the coefficient of, this is technically the kinetic friction, times the normal force. So if I get a model, if I get a value for the normal force, I can find the frictional force, and then I can do the problem. So that's why I'm using the y direction first. So what forces are acting in the y direction? I have a red pen here. Well, we have the normal force, and it's in the y direction. And then we have part of the gravitational force. That's the component of the gravitational force in the y direction. Okay, so how much is that? Well, that's just n. Okay, and then this is going to be mg times cosine of 25, because remember, cosine of theta is adjacent over hypotenuse, and so the hypotenuse is mg, the adjacent is going to be cosine theta times that. So my F net y equation becomes n minus mg cosine 25 equals 0. Now, there's a minus sign on that because when you're dealing with vectors, we don't have a negative vector. Okay, we don't say that's a negative vector. But now we're dealing with the y component, and so that's going to be either plus or minus. In this case, it's in the negative y direction, so it has to have a negative sign there. Okay. So I can solve for n. Now, this is a place where a lot of people make a mistake. They'll say, oh, I need n. Well, n is just the weight. N is not the weight. You see here, it's not the weight. Okay, well, I'm gonna put a box around that because it's useful. Okay, now let's do the x direction. The same thing. You'll see here I'm going to need the x component of the gravitational force right there. And instead of using the cosine to find that, I'm going to use the sine function. So in the x direction, well, we have part of gravity. It's going to be mg sine of 25, because now sine is opposite over hypotenuse. So to solve for the opposite, I would multiply the hypotenuse mg times the sine of 25. Make sure your calculator is in degrees mode if you use it like this, not radians. And then I have the frictional force in the negative x direction. Okay, so now what's next? I gotta go faster. I think I have a 15-minute YouTube limit. So now I can plug in the magnitude of the frictional force as mu n. Let me just put this as mu n, and then n is that. So if I rewrite all this, I get mg sine 25 minus mu times mg cosine 25 equals max. And I'm trying to find the acceleration. So I can divide both sides by m, and you'll see it cancels everywhere. So I get ax equals g, I'll just write it as this, sine 25 minus mu k cosine 25. Oh, that's it. Yeah, there's no over, I already divided by that. Okay, so we can just check a couple things here. Does it have the right units? Sine is a function that tells you a ratio. It has no units. And mu has no units. So none of this has any units. G has units of newtons per kilogram, which is the same as meters per second squared. So it is the same units as acceleration. So that's good. What if the angle goes down to 0? Then cosine of 0 is 1, sine of 0 is 0. I'm sorry, sine of 0 is 0, right. So this would be, it'd have a large acceleration and it wouldn't even be moving that way, really. What if the angle went up to 90 degrees? this would be 1, that would be 0, and you'd get g. It would accelerate down like it would be falling. Okay, so that's good. If you want to put a number in there, we can do that. I don't want to do that right now. Okay. But that's not the question. The question was how fast would we be going at the end. Okay, I'm going to do this using my favorite method. You know, some people may memorize one of the kinematic equations. I don't want to do that. How much time do I have? Oh, 10 minutes. Okay. I'm just going to use the kinematic equation then. So one of the kinematic equations says v squared equals v naught squared plus 2a x minus x naught. These are x velocities. Okay. And where that comes from, I'll show you maybe later. So if I release this from rest, this is the equation I want to use because I don't know the distance. I mean, I don't know the time. I know the distance. In fact, I don't even know the distance. Okay, because I got to get that. Here is my slide again. I said that was 5 meters, and that was 25 degrees. So what would that be? Well, let's call this x minus x naught. That's how far it went. The hypotenuse. So sine of 25 would be 5 meters over x minus x naught. And so x minus x naught is going to be 5 meters over sine of 25. So that's going to be in there. I found x right there. The initial velocity is 0. So the final velocity squared is going to be, can you see that? Okay. 2. Then I'm going to put that in for the acceleration. G sine 25 minus mu k, which I know, cosine 25 times this, which is 5 meters over sine of 25. That's it. And this has units of meters per second squared times meters gives me meters squared per second squared. Then I take the square root and it'll give me the right answer. No one will be happy unless I find the answer. So let me just put this in real quick. I got my calculator right here. And because I just want to make people happy. It's really all I ever want to do is make people happy. Okay, so I have 2 times 9.8 times sine of 25 degrees minus 0.31 times cosine 25 degrees times 5 divided by sine of 25 degrees. You could do some cancellations here, make it a little bit simpler. This says 32.8 meters per second. Which is, that's wrong. There's something wrong. Because that's 70 miles per hour. That's not how fast you would go. Okay, well there's a mistake somewhere. I'll let you figure it out. Okay, how about that?